We're going to take a look at multiplication of two matrices. The first thing we want to talk about is how do we know if we can multiply two matrices? So, for example, if I had a 2 by 3 matrix and I wanted to multiply that by, let's say, a 3 by 4 matrix, can that be done? And so when we were adding and subtracting matrices, we said the dimensions have to be exactly the same. That doesn't necessarily have to be true when we're multiplying matrices. So in order to be able to multiply matrices, what has to be true is the inside numbers of your dimensions have to match. So you can multiply a 2 by 3 matrix by a 3 by 4 matrix because those inside numbers are both 3. And that's what I recommend, is just listing the dimensions of your matrices that you're trying to multiply and then kind of check those inside numbers. If I switch this around, however, let's say that I wanted to take that 3 by 4 matrix and multiply it by a 2 by 3 matrix. That would not work because these inside numbers don't match, right? So this is a little different from like most multiplication that we think of. We think of like multiplying whole numbers, something like 2 times 5. We know the answer we would get from 2 times 5 would be the same answer we get from 5 times 2. So we know that when we have whole numbers, the order of our multiplication doesn't matter. That is not true for matrices. So you'll get a different answer based on what your matrices are, what order they're in. Or you may not be able to do it. Like in this case, I can multiply a 2 by 3 times a 3 by 4 matrix. I can't multiply a 3 by 4 times a 2 by 3. So you just want to check to start with, check the dimensions of the two matrices you're trying to multiply, and then look at the inside dimensions to figure out if you can actually do that multiplication or not. And then your answer, if you want to know what dimensions your answer will have, you look at the outside numbers. So I can't do this one, right? We said the inside numbers don't match. But if I look at the first one, a 2 by 3 by a 3 by 4, since the inside numbers do match, the answer is going to have the dimensions of the outside numbers. So my answer is going to be a 2 by 4 matrix. So let's look at this with an example and actually check and see, can we multiply the matrices together? And then if so, how do we actually do that process? So I'm going to look at this example. We have two matrices that I'm multiplying. So I'm going to just start by listing the dimensions. And I can see that this first matrix has 2 rows, 2 columns. And then the second one is also 2 rows, 2 columns. So in this case, they are both 2 by 2 matrices. But they don't necessarily have to be the exact same dimensions in order to be able to multiply them. What has to match is the inside numbers, and in this case it does, right? So the inside numbers are both 2, which means I can do this matrix multiplication. If they weren't the same, you would just say no solution. Reason for that being that the inside numbers on the dimensions don't match. And then my answer is going to have the outside dimensions. So in this case, my answer is going to be a 2 by 2 matrix. And I'm going to go ahead and I'm going to draw that a little bit big, but I am going to go ahead and draw that 2 by 2 matrix that I should be getting. All right, so my 2 by 2 matrix, this is going to have 2 rows and 2 columns. So there should be 4 spots in my answer. All right, so now that we know that we can do this, let's actually go through the process of doing this matrix multiplication. So if I want to just start, I can start with any of these spots, right? So I've got 4 spots in my 2 by 2 matrix. I'm just going to go ahead and start with the first row, first column. And so I'm going to start with this position. And what I do with matrix multiplication is I take the rows from the first matrix and I multiply them by the columns in the second matrix. So row by column, right? The rows from the first matrix by the columns in the second matrix. And so what I would do is I would look at which number am I trying to find. In this case, I'm trying to find what's in the first row and first column, right? So that means I'm going to take the first row times the first column, the first row in the first matrix times the first column in the second matrix. So that means I'm going to do 1 times 3 and 7 times 5, and then add those together. And that's how I'm going to get that one number that goes in the first row, first column. So I'm going to go ahead, this is going to be my work shown, and then I'm going to go ahead and write out my matrix answer. So in this case, this would be 3 plus 35. So it's going to give me 38 for that first spot. So you can do this in any order you want. I'm just going to do it row by row. So let's say that I want to go on to this spot. So since that is in the first row and second column of my answer, that means I want to take the first row times the second column. So I use my position where I am, what I'm trying to find, to figure out which row and which column to multiply. So since I'm in the first row, second column, I took the first row of the first matrix times the second column of the second matrix. This is going to be 1 times 3 plus 7 times 2. In this case, that's 3 plus 14. So that's going to give me 17. And I'm going to move on now to this position. This position is in the second row. So rows first, then columns, right? So the second row, and it's in the first column. So I'm going to take the second row on this matrix times the first column in that matrix. So 2 times 3 plus 4 times 5. It's going to be 6 plus 20, which is 26. And then finally, I'm going to do what's in the last row, last column. So I'm going to take the last row in my first matrix times the last column in my second matrix. This would be 2 times 3 plus 4 times 2. So that's 6 plus 8, which is 14.